Dun dun dun. Right. No, not the wrist. We actually need one midway between the elbow and the wrist, which is a little bit counterintuitive because you're like, you don't bend there.
That would mean my arm's broken.
That would mean I shouldn't have said what I said to that guy. Yeah, pretty much. No, the reason we need this joint here, it's a good guess though, is because we actually have to allow for twisting. Because essentially our forearm is comprised of two bones right there that twist over one another. Okay? So since we are working with single joint chains, we have to find a way to simulate that. And so what we need is we need a joint between here and here. Now there is a method to my madness. Usually when I explain to people, okay, we have to keep the elbow and the wrist and the joint in between them, including the break there, perfectly planar straight. I have one camp of people who totally get it, they got it, and they handle it. And then I have another camp of people who think, you could just kind of eyeball it. The problem with eyeballing something like an arm's joint chain at this twist level, I'm just going to give you a quick demo of why that would be bad. Okay. Good. All right. So we're going to create a locator. This time actually I'm going to create like a baby template, I guess. Just so I can make sure it's causing the problem that other people reap upon themselves. That's interesting. Oh, it is showing. It's just tiny. All right. So we're going to call this right here my forearm twist. Notice how I just kind of cavalierly said, hey, that's about straight between the two, but we can kind of see it isn't. Right? Tell you what, let me eyeball it better. Perfect. Not really, but perfect, right? All right, watch what happens when we draw this joint chain and we need it to twist for us. Okay. Let me get rid of these. All right, so here's my twist joint, right? So if we had created the arms this way and it was not perfectly straight, what you'd get when you went to twist your arm is you'd get a slight degree of variance on the, oh, maybe my eyes really are good. It's hard to tell, but this is actually wobbling, right? And so what you would have would be like, the guy that you misspoke to had broken your arm, and now when you went to twist it, your hand goes like this, right? Might have to create a more pronounced example of this.
Eyeball too well.
Yeah, it's kind of horrible, actually. It makes me look like a liar.
You lie.
All right.
Wait, I have a question.
Okay. Wait, I have a question.
Why didn't you tell us about this before we mirrored it?
Because I didn't want you not listening. Oh. Because that's the other thing that always happens. Ask me how I know.
At least you paused.
Because it has happened. Okay. So, forearm twist joints, horribly misshapen. Right?
Right.
Just take my word for it, if nothing else. Okay?
I believe you.
Believe me, I wouldn't lie to you. So, so the horrible thing here is, holy crap, I pulled a sneaky fast one on you. The bright side is it was all for your benefit, because there's this handy dandy tool called the Insert Joint tool that's made just for jobs like this. Okay?
I was going to ask you this. Insert joint tool, would it try to fit it right in the line?
I don't know. Hang on one sec and we'll get back to your question. So, I'm going to kill my character's right side joints because I'm obviously going to mirror them again.
With fire.
I'm going to mirror them with fire.
No,
Mirror him
delete it with fire.
That's a new one. Okay. No, we kill things with fire. We don't mirror them. Alright. So you're going to go up here to the skeleton joint. And here it is in all its glory. Insert joint tool. Okay? And you're going to click drag and release. And then hit enter to complete it.
You click and drag from a joint?
Yeah.
Okay. Was it selected already?
Here, I'll do it again.
Okay.
Quick drag and release.
I like spaced out where you click to find
Okay.
it.
Well, that's also.
So
Here we go.
it's
One more time.
Okay.
Show the tool again.
Okay. Skeleton. The one that says insert joint tool. You know.
Hey!
You know.
There you go.
Kind of like I said.
I wonder if it's already
10
going.
times. All right. So what I do, generally speaking, when I create this joint, is I do want it to be somewhat midway point, but I also like to try and... The geometry for Superman here is kind of better, because if he had one edge loop right down the middle here, it would mean that we'd have to do some creative weighting. But because he has kind of an edge loop over here and an edge loop over here, it's kind of made for us, because we can create a really nice blend between these two when it comes time to weight. So let me get my handy dandy insert joint tool again. Hit enter, and there we go. Now, obviously, joint 1 is crappy naming convention, so we might have to name this one too.
Do we have to, does it matter if we don't do that in orthographic? Like we have to do the rest of the
That is an excellent question. Always good practice to do it from orthographic. This one, though, this one you can do midway point. It's going to try and inherit its parents' orientation. Yeah, good question. Failing miserably. All right, something's going on here. Skeleton. Yeah. Yeah. Well, I do have the super fun computer today, apparently. Yeah, it was behaving so nicely earlier today. I don't know. It's like 6 o'clock hits and it goes, nah, not feeling it.
I'm
Too tired.
I'm tired. Leave me alone.
So L,
Enough.
4R, or 4M, if you are like me and can't spell. Bam. All right. And now it's in perfect alignment. We are good to go. Houston, we have no problems. All right. And now I'm going to mirror this. So I'm going to select the senior-most parent joint on one side of the axis, skeleton, mirror joint, YZ, behavior, LR. All right. Kabam! Insta awesome. Honestly, let me get through my spiel. All right. It's as much for you guys as it is for me. Because if I start looking at stuff and we get hung up on something, and then you don't get the information,
Ask you about it, right?
that's a problem.
Oh, okay.
Is it problem?
All right. Okay. So I'm going to get rid of these joints. At this point, you guys should have a pretty decent understanding of setting the local rotation axes. Should definitely have mirroring down now. Definitely should have mirroring down. Okay. One more thing. Setting rotation ordering. I do want to get into one more thing before we move on, as it relates to joints. There's one more consideration we have to make when we're setting up joint chains, and that's the local rotation order. And the reason for that is it's the way that rotation in an animator-friendly world works. Okay? Which kind of begs the question, but are there better forms of rotation in 3D? There are, but you're not going to be able to understand them or be able to animate them well, right? They have quaternion and double quaternion.
For what?
Mind-blowingly, who knows what, right? Hopefully you guys have had some 3D courses prior to this. You're probably used to seeing X, Y, and Z rotation channels when it comes time to rotate something or move it into place, right? That standard kind of rotation model is it's using what's known as Euler angles. And these Euler angles are, they're really awesome when it comes time to animate something because we are able to keep track of speed channels in our head fairly decently, right? That's not mind-blowingly difficult. But and it is? Okay. Well, if you're Raoul, then 3 is a rather large number.
It is.
Okay, fair enough, Raoul. But it does have an issue. With that ability for nice, neat organization of X, Y, and Z channels comes a downfall. And the downfall is in the form of gimbal lock and or loss of rotational axes.
Sounds like a troll.
Sounds like what?
A troll or something.
Oh,
A troll?
that's trolling.
He is a troll. He's the troll on your bridge of happiness in the way from your rig rotating properly.
Lovely. Lovely.
Kill it with fire.
I got it.
Burn the bridge down.
Such a good.
And now I can't actually get Cisco, so internet failing me. Oh, God. I love how they update systems so we can't, yeah, there we go. So we can't use them. It's brilliant.
I'm an admin.
Actually, it was awesome. The other day I was talking to Colin and he said it for me. He was like, oh, I can't get online, and just, he had like this little mini conniption. And I was like, awesome. It's true what they say, you know? Misery does love company, and it's that thing where you're not in a hurry, and you're on the freeway, and you're like, I don't need the speed. I'm good to go. I'm headed to the beach. Woo-hoo-hoo. And then the person behind you is just going back. Totally crazy, right? It's like this catharsis you reach. I love it. Anyway, that actually helps us. Moving right along. Although I will say, if ever you are having trouble in this class or feeling frustrated, pairing up with somebody, it is actually an excellent example of that, where you get to share some of that. You also get to rely on each other in case one of you missed something. You know?
Me and admin, I hate my notebook.
Yeah, you know, I've also heard other students had started like Facebook groups to kind of share notes or groups. Those are all excellent things. I'm a huge proponent of the idea of like setting up a meeting time, getting in a group, and like working on it together, because then you know it gets done. You all motivate each other. It's an excellent practice. Anyways, moving right along, I'm going to go to the ultimate source of knowledge. It's never wrong, even though you can edit it. Wikipedia. Is Wikipedia a standard university website that is...
Yes.
It's actually interesting because it's debatable. On the one hand, anybody can edit it. And on the other hand, go ahead and try and edit something that is public knowledge. I swear, if you try and edit something that people are all about, it gets changed like that. And if that rambling explanation doesn't work for you, I believe Stanford actually did a study on it, and they found it's actually just as credible as an encyclopedia. So, despite what people say, Wikipedia is actually quite credible.
Huh.
But the reason we're at Wikipedia is because I want to show you what a gimbal is. Kabam! I give you a gimbal and the huge, long, sciencey explanation that you guys can go through at your leisure. Enjoy.
Bunch of circles circling around.
Why do we know this? Why do we think this? Why? Blah, blah, blah.
Center of
The bottom line is they needed to know this so that pilots could orient themselves with the instruments. That's kind of how we came to this understanding. And this guy. But if you look at this as it's animating, you'll notice that eventually they all line up, right? Now our joints, unfortunately, have this exact same characteristic because that's how they rotate. They rotate in the same way this guy operates. Generally speaking, no matter what rotation order you have, you are going to lose an axis of rotation once you get to 180 degrees in one of those axes. Okay? So when you are drawing your joint chain, you actually have to keep this in mind and use a little bit of logic to say, okay, what are the common rotations I'm going to be using for this joint? The easiest example I can think to give, although I will admit it's one of the least significant because it's not a socket joint, and this usually affects socket joints much more so, like our shoulder. Hinge joints, not so much, because we can blow past the point where we lose an axis of rotation. But because I'm an anal retentive instructor, I still ask you to fix it anyways, because you have nothing to lose by doing it, and it's good practice. Okay? If I need to actually set up a rotation order for my my elbow here, the one axis I don't want to have lock out is the common axis of rotation, right? The one that allows me to do this. If it gets screwed up in some wonky way where it's like your arm is breaking, it's no big tragedy because you're probably not going to be bending it that way anyways, right? Now the same logic, fortunately or unfortunately, applies to other joints as well. For example, the leg joint, which you can move all around because it's a socket joint. So in the case of something like the leg joint, you have to determine how much flexibility you need. Now, I'm not going to show you my awesome kung fu moves and throw a kick here, because I don't want to break monitors and I can't afford it. But we all know that there are those people like me who are able to touch their foot to their forehead. Okay, all right, I'm lying. Maybe it's a little bit of a stretch. But your character may want to do that, right? So we definitely want to keep the axis that allows you to swing your leg forward and back, right? It's going to be a common one. Twisting, I can't twist from my hip too much. Yet I may want to offset my ability to twist with my ankle. So I'll keep that in my mind. My leg out to the side, well, I don't know about you guys, but I don't know. My awesome martial arts didn't really allow me to do the splits very well. All right, maybe martial arts is a stretch. Well, quite frankly, I'm not that flexible. But if I were,
Which you're not.
which I'm not,
Hypothetically, you are.
that's the other axis. I would want to make sure didn't get locked out, right? Because I'd want to make sure that I have enough rotation. So I have to determine going into this, is my animator, or me, if I'm animating, going to need more of that twisting movement so I can really exaggerate things, or am I going to need more of that? Because at a certain point, I'm going to lose some functionality, right? Which is actually to say the 180 degree mark is actually where it's going to line up with something else. So right now, you got the theory of it. Let's actually have a look at how we set this crap up. So I'm actually just going to hide the geometry here for a second. Kabam. And let's actually look at our elbow since I was talking about it. So by default, your rotate tool is not going to give you a visual display of what axis is locking out. You're going to be left going, I don't know, it's one of them, right? And then you're going to go to animate something, and it's going to flip or do some kind of odd behavior, and you go, you're going to freak out, and you're going to hate Jonathan. Well, you said it. So here's how we give ourselves a visual display. Go back into the tool settings of the rotate tool, and instead of local default, which is what it is at default, switch it to gimbal object. And you'll notice that my rotate tool now looks a little bit different. I no longer have that outside circle that allows me to manipulate it per the camera's view, right? Instead, it's limited down to the 3 axes of rotation solamente. Okay? Watch what happens when I grab Y with default settings. You see how the little red curve is lining up with the little blue curve? That is no es bueno. Okay? Yes, that's how much Spanish I speak. You've heard it all now. So this is not what we want. And the reason we know this is because this is the common axis of rotation for this, right? It's a hinge joint. It's going to bend that way, right? If you look at your geometry, you can tell. Yep, that looks like the inside of the arm. It's going to bend that way. So when you see this happen, where it's locking out, that means at this point right here, that 90-degree point, oops, I broke his arm. Sorry, minus 90 in this case. You now only have two axes of rotation. Third one is, bam, gone, right? What if I want to rotate it up like this? Well, in order to rotate it, in order to rotate it around this way, it would literally have to flip around. It would have to actually it would have to right itself like this and reach some kind of compromise between these three axes, right? So that's kind of a pain in the butt. We don't want to have the potential for this functionality here. And so the way we correct for this is by changing the rotation order of these joints. And once again, this is going to apply to every single joint. It's going to be your logic and what you intend to use this character for that is going to determine which one you decide on. So if I go Control A here on the arm, under the attribute editor, which I always tear off because it gets in my way, you're going to have this L elbow, which is what we have selected. Under Transform Attributes, there's a section here called Rotate Order. Right now it's set to X, Y, Z. Huge X and 5. If you drop down this box, you can choose a different rotate order. So let's say YZX. Okay, let's set YZX. If I hit E on this guy, look, it's no longer losing an axis of rotation on the Y rotate. Okay? So as far as the elbow is concerned, mission accomplished. Right? Let's see. Okay, so let's have a look at the shoulder here, right? Now the shoulder, it moves up and down just fine, right? Figure the amount of, what I do is I get up and I imagine I'm the rig and I see how flexible I can raise, my stuff and how I, like you saw me a second ago with my awesome kick that I threw. Which was about this high. Which was about this high. It was like that.
You said it could touch you.
Yeah. Huh? I said I could touch. Yeah. Well, I'm not going to show you. I don't want to break things. You just have to take my word for it.
Okay. Yeah. Why would you lie?
Why would I? I wouldn't, right?
Like the cake is a lie?
Wait, portal? Yeah. All right. So I'm going to look at my rotations. I have to figure. Okay, if I rotate down, then X is going to be, horizontal like that. Am I going to need to twist it like that? I don't know. Maybe if I want to accentuate something like in the forearm, but generally speaking, I'm not going to get a lot of range in twisting from my shoulder, right? So right now, our X rotation is a pretty strong candidate for being the one that locks out. Because we're probably going to need to Z, and we're probably going to need all this movement, more so than Z. So let's see if we can find a rotate order that accomplishes this for us and allows for us to do this. So let's try YZX. Try it out. Nope, because look, you see it, right?
Sorry, you don't need.
It's causing us problems. Not only that, problems. Okay, so far, ZXY allows for Z rotation, like we want. Let's see if it allows for Y rotation. Okay, it does. So ZXY would be a good one in this, because it's going to lock out in the X channel. You see that? And I'm probably not going to be twisting terribly in the X channel from the shoulder. So, does that concept make sense to you guys? Okay? So, the two things you guys, the three things, you don't count so good. The three things you guys are going to have to go back through in your individual skeletons now to fix is, one, you need to insert the joint for the forearm, okay, for the forearm twist. If you got that already, because I've been blathering on, well, more power to you. Just make sure you mirror it so it's exactly the same on the other side, right? We need it to match up. Okay. 2, you need to go in and correct the local rotational axes so that your spine doesn't compress in on itself. Or in the case of fingers that are possibly going wrong, those. Okay? And so that's, just as a refresher, you're going to go into the component mode. You can just click on the question mark if you want, or you can specifically isolate local rotational axes, choose the joint chain you want to look at.
You just deselected.
I know. I'm just going to blame my illness. Can I do that?
No.
Okay. I do want to point something out, though, since we're here and I have the opportunity, almost thought. This is what happens when you use mirror behavior, by the way. And this is why mirror behavior works. Notice how Z is in one direction on the positive side, and Z is in the other direction on the negative side of yeah, thank you. This is fine. This is fine for all of the limbs that fall on this side, because what it's doing is it's making sure that the behavior, the way that the joints on the character's right side operate the same as on the left side. That's not a mistake. That's actually intentional. If we had chosen orientation, Y would be up on the right side, and X would still be pointing away. It would be pointing away from the children, going down the joint chain. So it would literally take in the exact same values. And it might just be easier to demonstrate this. So if I rotated 10 in Z on my arms, they basically do this. Like hands in a clock. They'd go in the same direction if I use orientation. Behavior does this. Makes you flap your arms, right? In order for it to achieve that, it needs to do this. So that's fine. The ones you want to look out for are the ones that are inconsistent. So if you find a joint chain that is comprised of hinge joints, like, say, your index finger or something, and one of those is flipped, but the other ones are all facing one direction, it's not going to operate correctly. It's actually going to do what the spine did and compress in on itself. It's highly unlikely you guys to set it up that way, especially if you've been following along at this point, but I want you to know what to look for. Basically, what we saw in the spine, with Y pointing in two different directions, right? We want to make it consistent. Does that make sense?
Yes.
All right. Okay, so that's 2. Fix the local rotational axes. Get in the forearm joint. And 3 is go through your joints and use your logic to determine the local rotational axes so that you don't lose a common axis of rotation. Does that one make sense? Yeah.
Yes. Is this also something that would have been easier to do if we didn't mirror the joints and like fix that and then mirror the joints?
Yep, that'll speed it up. And by now, I'm sure you saw that it takes all of, what would you say, 5 seconds to mirror joints?
Yeah.
Not a,
do it per joint.
not a big loss. You don't have to do it per joint. You have to do it per joint chain.
Okay.
So in this case, your mirroring would be all of the shoulder and the hip. Sorry, I'm keeping work on you.
No.
Okay. Oh, one more thing I did want to point out, just in case you guys were curious. Remember I was telling you that the last joint in a joint chain always aligns to the world? If you look at it, you can see. See how this one's aligned with the world? This one's aligned with the world? Those are the last ones I drew. So if those ones don't correspond, don't sweat it. They're just termination points in the joint chain anyways. You can rotate them however you want. Okay? And make sure when you're done, you switch your rotate tool back to local object or local default. Because if you're on gimbal, you actually can't change the local rotation axes. It won't allow you to. It'll freak out. Okay? All right. So we are at 7:29. You guys feel need for a break before I go on? Yeah?
Yeah.
All right. So